In this section of the course, we'll learn how to deploy our function to AWS Lambda. We'll configure the settings for the function, and then we'll create test events and then test the function. We'll analyze logs in CloudWatch and look at monitoring in Lambda and detailed monitoring in CloudWatch. To deploy a Lambda function, log into the AWS Cloud Console, search for the Lambda service and click Create a Function. Here we'll choose Author from Scratch and give our function a name. We'll call it Hello Lambda. A function on Lambda needs to have the necessary authorizations to access resources on AWS. Our first function only writes to the CloudWatch log, so that's the only service we need to give access to. We'll create a custom role for our function. When we select Create a Custom Role, a new tab will open up in our browser where we can create the role. Select Create a new IAM role and give the role a name. We'll call it Hello Lambda Role. The default policy document for this role contains access to the CloudWatch log, so we don't need to edit the policy document for now. In later chapters of this course, we'll get into more detail on how to edit and create policies. Click Allow to finish creating the role. The Hello Lambda role is now selected for our Lambda function, and we can create the function.
The function is created. We choose the runtime and configure the Lambda environment for the function. As a runtime, we will choose Java 8. And the handler is what method in what class needs to be executed by our function. In our project, the package name was be.quadlibet.hello Lambda. The class that we created was called Hello Handler, and the method was called handle request. We need to put 2 colons and then the name of the request here, and that is the handler that will be called when our function is executed. We upload the fat jar file that we created as the function package. So here we have the big file, the jar with dependencies. That's the one we'll upload. Now, the Lambda function configuration also allows you to configure environment variables. It can be very useful for many purposes. If, for example, you want to use the Lambda function to write files to a specific S3 bucket, you don't have to hard code this in your function, but you can provide this as an environment variable. In our example, we don't use any environment variables, so we can skip this section. Tags are AWS's way of grouping different services together. This can be used for reporting or for separating billing. In the basic settings section, we can choose the amount of memory our Lambda function can consume. In Lambda, the memory is the only lever we have to control the resources the function has. The more memory we assign to the function, the more CPU power the function will have. There is no way to control CPU power independently of memory assignment. The cost of the execution of a Lambda function is calculated in terms of memory assigned and execution time. Since our function is pretty simple, we'll assign it the minimum amount of memory, 128 megabytes. You can also specify a timeout, and that controls the maximum amount of time the function is allowed to run. You can set this from 1 second to 5 minutes. Here, we can also provide a description for our function, which makes it easier to identify later in our Cloud Console. In the networking section, we can control where the function runs. By default, all Lambda functions run inside a virtual private cloud, a sort of private network within AWS Cloud. Here you can select a custom VPC you want your Lambda function to run in. For example, if it needs to access a database instance that you already have running inside a VPC, you can select a specific VPC there. For now, we don't need this. It's also possible to set up error handling. So Lambda will send information about failed executions to an SQS queue or an SNS topic. This is useful when you have a very high load that needs to be processed by your Lambda function. Once we have our settings specified, the fat jar file is uploaded. Now we can start testing our function. We click Save, and now our jar file is uploaded. And after that, we can start creating our test events. Whenever you want to execute or test a Lambda function in the AWS Cloud Console, you need to specify a test event. For that, we can click on the Select Test Event button and click Configure Test Events. Test events are JSON representations of objects. The format of our test event needs to have the same structure as the hello input class that we created. That class had only one attribute. It was called name. So let's provide a name attribute with a value. That's the only attribute that we had in our event. Let's call this valid test. Create a test event with a valid input object. Now, in order for us to also test failures for our function, we'll also create a invalid test. Our invalid test, instead of providing a string value for the name as our function expects, will provide an object for our name. Our function will not be able to handle this type of input, so our function will fail when we try to execute it. So now we have our two test events. Now we can start executing our function. Let's first select the valid test from our test event dropdown and then click the test button. The first execution will always take a little bit longer because it has to spin up the container in which the Lambda function runs, but after that executions should go a lot faster. For our function, it was a very simple function. It took the input name and then returns a message, hello student, and it also returns the function name and the memory limit. You'll also see the log output of the function execution, and this will always include the duration, the build duration, which is the duration that the function ran for, rounded up to the closest amount of 100 milliseconds. The memory size is also displayed and the maximum amount of memory the function used during runtime. You can always use that information to control the memory size and runtime limits for your function. Over-provisioning memory will impact your cost, as you pay for the provisioned memory and not for the used memory. In addition to that information, the log will also contain the message that we wrote to the log in our Java code. So we put a message student said hello in that log. Now, this is just the log information for this one time we executed it, but all of the logs are written to a CloudWatch log group, and we can click here to directly go there. So each execution will provide it as a log stream, and in the log stream we see basically the same logging as we saw in the Lambda section as well. So we get information that it started, which version it ran. We get our log message that we wrote to the log, message that it ended, and then a report with all the information about how long it took and how much memory it used. Returning to our Lambda function, it's also possible to look at more summarized information about our function. To get more relevant data in there, let's test our functions a few more times with both our good and our bad test event. Here we executed the invalid test and we see that there was an error message during JSON parsing because we provided an incorrect structure to our input object that our Java function was not able to handle. Let's do this a few more times. Now we have a few successful executions and we have a few failed executions. Now let's have a look at the monitoring tab. In the monitoring tab we see 6 graphs. The 3 first are the most important ones. In the first one, we see how often our function was executed within a specific time frame. And the second one, we see how long it took for the function to execute. So we see in blue the maximum runtime and in green the average runtime of our function during a specific time frame. We also see the errors that occurred within our function. This is summarized information and always represents the last 24 hours. We also can click on each graph. For example, if we want to see how many errors we had at which time in the past, we can see a historical graph of all the errors. In this case, we just have 3 errors a few seconds ago. And the same type of graphs you have also for the invocation durations. You can see how long the function took at a specific time. So this gives you a lot of information so you can monitor your AWS functions and really take into account how long they run, make some improvements, and make sure that you're not run into any unforeseen circumstances. This concludes this section of the course. We learned to deploy a Lambda function to AWS, configure the settings for the functions, create test events and test the function, analyze the logs in CloudWatch, and look at monitoring Lambda and detailed monitoring in CloudWatch.